like to introduce the Chief Information Officer for JP Morgan Chase, Melissa Goldman. If you could come up to the stage, please give her a warm welcome.
And so in my capacity of CIO of the corporate functions within JP Morgan Chase, I also have a lot of responsibility when it comes to things like bringing innovation and change to the organization. And in that capacity, one of the elements that we use regularly are things like artificial intelligence and machine learning. And so I'm coming to you guys today to talk a little bit about kind of what that is, so that you have the definition of it, where it's applied in your daily lives as well as in the bank. And for those of you who are interested, how it can be used and how you can take the opportunity and learn more about this in your own spare time or through academics. Thank you. I'll also remind you that I make a lot of hiring decisions for the engineers that come into JP Morgan. So for those of you who fall asleep during the little lecture that I'm doing, I'll remember your face. Get my phone out and take a picture. No, but seriously, like JP Morgan has 50,000 engineers around the world, and in a lot of the skills that these engineers are bringing to the organization, this is definitely a topic that is emerging and important to the bank. So when we think about data has a lot of different dimensions of its use. Not every bit of data needs to go into a machine learning or deep learning model. There's a lot of value that we can get out of data just from different kinds of products and tools that we can bring to it. So everything from analytics and visualization and some of these deterministic models that we have are all really important ways that we as an organization and across all the enterprise can get value from our data sets. Sometimes even just being able to plot those data sets in front of us and understand what they look like can give us insights into information that we can't otherwise see as human beings as we sift through different elements and parts of it. We just don't always have the scale to do that. And so getting value out of data doesn't necessarily always mean you need to apply a neural net or some really complex model to do it. Sometimes the activities that we can use are much simpler. And so it's really important when you think about what you want to get out of information and what is the right tool and technique in order to do that. So with that, I'll kind of ask the group, does anyone know what artificial intelligence is, or even the difference between artificial intelligence and machine learning? No? Okay, well, thankfully enough, I made a slide on it, so we can actually cover it here. But artificial intelligence is a much broader kind of topic. It's not always about models and calculations. It is how we bring sort of techniques with machines and algorithms that otherwise a human would be able to do. And so it could be as simple as if-then-else kind of activities. It doesn't have to be a model or a calculation that we put into the machine learning category. Now, machine learning itself it's a subset of artificial intelligence. And it's really about the models and the capabilities that we can bring that give us insights and information around data sets or allow us to actually perform other kinds of tasks that would otherwise take humans a long time. And then I've also included deep learning, because sometimes you hear about some of the complexities in some of these models that have these major neural nets that take enormous amounts of compute to run, and that's within the deep learning category. So again, there's different kinds of categories of things and automation that we can bring to the world through different kinds of techniques, and these happen to be subsets of one another. Now, although there's a kind of resurgence of machine learning, and we'll talk about kind of why that's the case today, artificial intelligence has been around for decades. Even back in the ancient times in Greece, just thinking about modeling kind of human career and what could happen. These were thoughts that were out there. But the coin of machine learning actually came about back in the 1950s in a event that happened at Dartmouth College, where they kind of coined the phrase, and it was really around trying to mimic these human behaviors. When any new concept comes out, right, there's always this need to invest. And there was a period over time where people were not as enthusiastic around the opportunities that these capabilities were going to provide. And therefore, there was a lot of funding that had dried up within the government, and there was a bit of what they called like a winter, an AI winter, and pessimism around that. But as the theories evolved, as investments in the 1980s began to emerge again, and certainly things that have changed over the last couple of years that we'll talk about in the next slides, it has been an explosion of capability in this space. So what's happened recently? Like, what are the changes? What's going on in the universe of technology and infrastructure that's allowing the use of machine learning and the value of it at the scale that we're seeing today? So first and foremost, the cost of actually running functions and storing data has changed materially. Does anyone know what the public cloud is? AWS, Google Cloud, Azure, Microsoft's Azure. All right, so I'll tell you. Companies over the last number of years have identified that they can actually scale compute and storage in a way and do that on behalf of companies and institutions and businesses out there, and individuals for that matter, who actually want to be able to leverage it and run it. So if you yourself said, hey, listen, I want to store a whole bunch of stuff, you'd have to go out and you'd have to buy a lot of machines to do it. If you said, I want to run some calculations that are really intensive, but I don't necessarily want to run them 24 hours a day, 7 days a week, the idea, right, of this public infrastructure that's out there, that you can go to one of these companies, like an AWS, or a Microsoft, or a Google, and say, hey guys, I want to rent some of this from you. I want to rent some storage because I have data and information I want to keep around for some length of time, or I have a calculation that's going to run for the next 15 hours on lots and lots of CPUs and GPUs, but after that time I don't need it anymore, and give it back and somebody else can use it, right? It's this idea of the rental and the idea of the scale that these companies have, that they're able to offer this infrastructure in a kind of way that is much cheaper than if any individual wanted to buy it themselves. And so with that, and with other things like the fact that, do folks know what open source is? I'm like trying to see if that's the open source. You want to give it a try? To the public, yes. Right, so it's what the gentleman said was it's where the code is available to the public, right? It is a way that we have as a society organized ourselves to actually share more than we ever shared before. So we're able to contribute to what we call the open source community, right, which allows people who previously didn't have access to the good work that was being done by organizations or individual and actually pick it up and leverage it. So when you think about the combination of the fact that I can now get my hands on like the things that will help me make a machine learning problem run and scale, and I can actually also get my hands on the models, the investments that different areas have made on the algorithms and how the calculations actually take place, coupled with the fact that we've got this enormity of data. And by the way, some of the data sets that are out there, and we'll talk a little bit more about that later as well, some of the data sets that are out there are public. So information about language and books and other things that include like what people are buying and stuff of that nature. You can actually get your hands on and run these kinds of algorithms. That's all now at your fingertips. You can leave this room, go put your credit card down with Amazon, create an account, and start playing with not only the ability to get all the infrastructure to support it, but actually access to a lot of the models and things that you can then apply against these problems. And so the lack of friction or the ability to do some of this work is easier than it's ever been. So when you consider what constitutes a good data science or a good machine learning kind of challenge, right? It's not enough to just be a modeler, right? You actually have to have a business problem. You have to have something that you're trying to solve for. What are you trying to do? Are you trying to figure out kind of what an individual's next purchase might be? Are you trying to figure out what the best route might be on a map in order to get from one place to another? Like really understanding what the content is that you're trying to solve for. Every problem requires somebody with that subject matter expertise who can understand what the business challenge is and what we're trying to solve for here. And then you need sort of the software. What are the things that are going to then you're going to be able to bring against your data and your information and run? The data science practitioner, right, is actually picking up that model and they're tweaking it, they're tuning it, they're looking at the different variables or saying, you know, if I modify this slightly, do I get a better answer out of it or not? And then very often you need your technologist out there who's figuring out how to make the whole thing run together, because without these pieces and understanding what it's going to need to actually produce results, and then finally we need governance and the control oversight. And we're going to talk a little bit later about why that particular role is really important, because sometimes, you know, we use products, we use tools out there, and we don't always understand the implications and the downside of some of these tools. So we'll go through that. So machine learning, as mentioned, is reasonably vast, and you can probably look at documentation that's out there, and it talks about the different kinds of things. What I've done here is I've highlighted 3 different ways that we train models, and it's important to understand that a model is only as good as sort of the information that goes into it and the model itself. And so well, the models generally need to learn information. So on the first one, we call it supervised learning. And so what this does is it expects that there are some inputs and outputs. There's inputs into the model, and then there are results of the model. So for example, if you were, we use this in like the fraudulent transaction behavior. Talk a little bit about that later, but what happens is you go to swipe your credit card or your debit card, and one of the things that the banks do is they try to figure out, is it really you that's making that purchase, or might it be somebody who's stolen your card, or a fraudulent transaction? Now, it needs to know what a fraudulent transaction looks like for you in order to figure out whether it's you or not, or what the profile of you looks like. And so this is the case where we have lots of inputs into it. We have all the transactions that have taken place, and we also have within that which ones were identified as fraud. And what we do is we take that set and we go and we evaluate that, and then the model learns from understanding what are the attributes and what are the characteristics of a good transaction versus a bad transaction. So when the next new transaction comes in, it can figure out whether or not it was a good one or a bad one. Unsupervised learning doesn't make assumptions around output. It really doesn't know what the answer is. And as a result of that, it's really more around finding characteristics and patterns in the data. It looks at different groupings of things and sees how they cluster around each other, or the distance an answer has from a different answer. And so unsupervised learning can have a lot of value, you need a lot of data sets with these kinds of characteristics to actually make them work. Things like customer segmentation is one of them. And then finally, reinforcement learning. And that is where the computer makes decisions, or the model makes decisions about what to do. And based on whether the model got a good reaction to it or a bad reaction to it, it will know and it will learn whether or not the action that it took was the right thing, and it gets smarter and smarter as it makes more decisions and understands whether or not it had a good reaction. All right, so supervised learning. This is one example of where we had some supervised learning, and so it is trying to identify, trying to categorize a picture, and is the picture a dog or is it a muffin? And as you can see, right, these aren't necessarily easy. I know you guys are squinting and trying to see, but figuring out whether you've got a muffin in front of you or a chihuahua, not always the easiest thing. And so what has to happen is we need to show the model lots of these pictures. And we need to tell the model, this picture is a chihuahua, this picture is a muffin. And after we do that enough times, the next picture that shows up that looks like it could be a chihuahua or a muffin, the model can figure out which one it is. But again, if we don't instruct the model correctly, if we're not precise around the data that we send into it, and we tell it some muffins are dogs and some dogs are muffins, right, the model is not going to know any better, right? The model needs to get good inputs in order to get good output. So on unsupervised learning, right, this is more about let me put the data out there and let me have the model figure out what's interesting about the data. What can I learn from the data by different characteristics and attributes of it? And so in this particular case, right, we see that the clustering, like we have clustering of information. This might tell us about certain types of clients and what their next product might be, or what they might need from a services standpoint. And so again, another technique that we use, but we're not telling it a right or wrong, or we're not inputting labels. We're actually just letting the data enter the model, and then we get the output that looks like this, and we need to make those determinations. And then the last one I'll show you is reinforcement learning. Now this is where the model is learning how to play Pong. The computer is on the right-hand side, and what it's doing is it's going through many different scenarios. It's going through game by game, and it's trying to figure out which way the paddle needs to move in order to have a good effect. A good effect would be it hits the ball, right? Or Pong, whatever. The bad effect would be that it misses and it loses the game. And so that's the reinforcement. It's the computer learning that certain things, based on the other stuff that's going on the screen, results in good effects versus bad effects. And you can see after just 10 hours of training, and by the way, depending on what kind of machine you're running on, this could be much faster, but before you know it, the computer can outplay, any opponent. Now we're going to watch this for the next half hour. No, just kidding. But yeah, it's an interesting, example. Also, things like reinforcement learning, you'll see in driverless vehicles, right? What you're doing is the car, right? When you allow the car or the model to make decisions, it is identifying what results in a good or bad behavior. And so a lot of these techniques are used in driverless vehicles. Okay, so we talked about the different model types. I'm going to talk a little bit about the application of those model types to different kinds of problems. Now, it's not always that there is one model type that can apply to a particular problem. Sometimes multiple different kinds of models can apply to these. Has anyone heard of natural language processing? Okay, no. Okay, natural language processing is really where the computer has learned language, right? It figures out relationships between words, it understands sentence constructs, it understands, to a certain extent, some of the meanings of the words so that it can synthesize summaries about information, sentiment. How did this paragraph that was written, like, was that paragraph a positive paragraph? Was it negative? You can use it in call centers, like when you call up and you're complaining about, you know, whatever you ordered online, it doesn't work, and you're talking to the service center. That kind of language can be interpreted. Was that a positive call or was it a negative call? Was somebody calling up the call center to give positive? And, you know, how often does that happen? Not very often, right? How often you call up and say how wonderful your product is? But anyway, you could look at that on social media. There's so much language that's out there. There's so much that's written that being able to leverage a computer to be able to go across information in a way that no individual or human being or set of people could do is a very, very powerful tool. And so we have natural language processing. We have classification. Again, we talked a little bit about that in the previous, how do I look at a set of things and put it into a certain type of category. Anomaly detection. I talked about kind of the fraud example. We do a lot in the bank on fraud. It's not even so much on, credit card transactions, but if there are sort of bad people, money launderers in the environment, and they're trying to do different techniques in how they introduce cash into the system, and there's a whole lot of characteristics around trying to find that needle in the haystack, and anomaly detection is really important for that. And something like predictive analytics, right? We're trying to anticipate what might happen next. And in that, it can be something like what's the customer going to buy? Or we'll talk about an example, what might happen in the stock market tomorrow that's going to, create an opportunity to buy or sell a stock. All right, so who thinks machine learning and AI is resident in your lives today? All right, I know I'm kind of giving you the answer, but we'll go through a couple, and if other people have examples that they want to share as well, we should do that. But who knows how Netflix, the thumbnails work? Anyone? All right, so one of the things that Netflix wants, who uses Netflix? Anyone? All right, good. Phew. One of the things in Netflix, right, is they want to entice you to click on and watch their content. And how are they going to get you to watch their content, right? They're going to get you to watch their content because they're going to be able to serve you up a picture of what's going to happen in that movie or in that TV show that is going to be compelling to you, right? And so, if you are a person that really loves car chases or cars blowing up or cars in general, right? If there is any picture of a car that happens in a movie, it might not be the theme of the movie. In fact, there might not be a car chase in the movie itself, but it might be on the movie, a movie that they're watching in the movie. But needless to say, it is, if you are someone that is more likely to click on that button because it shows you cars, then they're going to show you cars, right? If you are a fan of romance and always click on a picture that exudes romance to you, a couple or something going on in the film, a little bit of skin, then you are going to get the Netflix thumbnail. Sorry, I'm in trouble for that. You're going to get the Netflix thumbnail that shows you that, so that it entices you. That is behind the scenes processing of your data, knowing you, knowing people in your segment, knowing what interests you, figuring out how to pull you into that. I mentioned before an Uber, right? It's, the routing. What's a differentiator for Uber, right? Differentiator for Uber might be, routing and making sure that the car is taking you on the path that makes the most sense and is the most efficient. Understanding traffic patterns, understanding inputs where construction is happening, time of day, all these different elements that are not naturally going to go into a standard kind of algorithm, but actually require a lot more iterations, a lot more data behind it. That's where we see the value of machine learning. We've got, like Grubhub. Who uses Grubhub? I'm a seamless kind of gal, but Grubhub, yeah, okay, so we don't know Grubhub. I'm looking at Nick, because Nick helped me build the presentation, and he's the closest to a millennial or Gen X that, yeah, anyway. Gen Z, what are you, Gen Z? Zoom. Yeah, Gen Z, okay. So we're not going to go to Nick for current Gen Z activities, but Grubhub, Seamless, Uber Eats, the whole range of them. Do you have a question? Yeah.
So, if we can train an AI to beat humans in our most complex games, millions to one, and we're implementing that same technology in things that, like Netflix, Instagram, Snapchat, in which the qualifier is that we spend more time looking at it, at what point does this become dangerous? And AI is training us?
Yeah, well, yeah, when will robots take over the world? I don't have the date for that, but what we will do is, I think, in the next slide, we're going to talk a little bit about the dangers of AI and why it's not the answer for everything, and why in a lot of cases, kind of human input and the complement of AI and human beings together is actually ideal, but to be honest, there is an enormous amount of untapped potential of this capability in the world, and so we are going to see, I think, over time. And when we think about things like, what the workforce of the future looks like, and what are the jobs that are going to be out there in the next 20 years versus what we have today, I think we do need to be very thoughtful around kind of what are the skills and what are the dimensions of that, and hence why I used to go into my kid's bedroom at night and whisper, "Data will rule the world," right? And until they fell asleep, over and over again. And so, I actually do fundamentally believe that, that there will be changes in the way people work and operate that are going to be reflective of this, but it's not going to be, robots are going to do everything. That's just not. There are skills that human beings still bring to the table that will never be replaced by this. But you get it. It's LinkedIn. And I'll tell you guys, when you start to, I know you're freshmen, but when you start to think about, you're interviewing and looking at different jobs out there, there is, the reality is there's more and more use of machine learning and AI in the process, in how organizations and different companies are thinking about identifying what is the right match. I don't want to suggest, yeah. I'm sorry. Yeah, sorry, you're right under the light. Yeah.
It's all good. So I just have a question about the privacy side of this AI technology. I understand that when before the initial use of any of these applications, there's like a form or a contract that you sign that kind of signs away all your rights, in one sense. But in another sense, like, what does that kind of mean for privacy, especially for when in special cases where like it's even happened to me before, where I've been having a conversation with my friends about, I don't know, anything. Let's say it's food, and then the next thing I know, Google ads match what I was just talking about.
Yeah.
So how does this incorporate into privacy and security?
Yes. So that's a great question. I don't know, did everyone hear it? All right. So the question is around as data is collected on you, right? As information. And by the way, what is it? It's something like, I don't know, somewhere between 70 and 100 times a day, you end up on some video somewhere. Like, you don't even know it, right? There's cameras all over the place, and so the average person just walking down the street, there's pictures of you, like, all over the place. And so it is a serious question around what are companies and organizations entitled to use of yours? Is your data your own? Like, do you own it? And in a lot of cases, and you've heard in the news, are you, when you agree to actually do business or to go onto a website or engage in activity with any one of these vendors, your companies, you're actually clicking on something that says that they are entitled to use your data in certain kinds of ways. And this is a ever-growing topic for our governments, for all industries. You see it in all the stuff with Facebook and elections and how are we being, manipulated by this data. So what we are seeing, I can tell you, right, I am by no means a privacy expert. However, because of the job that I do, it's something that we have enormous sensitivity to. When we think about using a customer's data, are we using it to their benefit? Are we using it to their benefit, or are we using it, to the firm's benefit? If, the idea of how we're using it ends up on the cover of Wall Street Journal, are we going to be proud of that, or are we going to be embarrassed by that? And so a lot of organizations, even with the context of like signing on the dotted line that your data is allowed to be used, there are things like, we call them data usage councils, and things within an organization with the right governance structure that take place. In addition to that, right, in addition to what I would call corporate responsibility around the topic, there's a lot going on within regulation and governments. There's a, California privacy law. Are you guys familiar with privacy laws? Yeah, probably not. Yeah? Okay, good. So some of you may have come across it, especially if you've got particular interest in it, where, certain states are starting to think about, what's appropriate for a consumer to be able to do. And in certain jurisdictions, not only in the US, but around the world, there's new regulation and additional regulation coming out that basically gives certain rights to the individual, which forces companies to delete all their data on that individual if that individual comes and says that they'd like it to be deleted, and then you have to sort of prove and demonstrate that you've done it. So it is very much an evolving field, I would say. And I'm fascinated by it because I think, there's a real opportunity here to make sure that, data continues to be used for the right reasons. And in a lot of cases, it gets out of people's hands. I will tell you, my experience in talking to a lot of your age group is very much around, as long as I'm getting value from it, let them do what they want. Like, as long as they show me in the next product, or, I was talking about going to Florida, and now all of a sudden I've got the best, price for a ticket to go to Florida, next week, showing up in my, social media feed. A lot of people feel like as long as it's bringing value, then it's okay, but again, it's a slippery slope. So there's a lot more that's happening and a lot more to come on this topic. Yep.
Okay, and then I just have one more question about the other half of like the privacy issue, in the context of like non-consensual use of the AI, where like, for example, I'm not sure like how recently it was, I think it was probably like last week or so, but there was the owner of the Gristedes grocery line. He was having a meal in a restaurant in Manhattan, and he noticed his daughter came into the restaurant, sat at a different table, and was on a date with an unknown, was with a male that he did not know.
Right.
So he asked the waiter to take a picture of this individual, and he comes back and he puts it through this app called Clearview, and he finds out all this information about him without consent. How do we address that?
And by the way, I appreciate the passion around it, in part, to be honest, because I feel like there's almost a lack of understanding around what the implications of this means. I don't have an answer on how you might personally address it. I know there's many people that choose to have, Nick included here, choose to have a very, very low profile on kind of social media, not having pictures out there, stuff like that. That's definitely, one way, but then you lose the advantage of all the valuable things that having your data out there means. And so what I think is going to happen is that there will be more responsibility put on the companies that are ultimately using this data, and that we're going to see a lot of legislation around it. I can promise you that, you know, governments and governments not only in the U.S. but around the world. I mean, have you been to China? I mean, anyone here from China? There's a lot of, right? There's a lot of your own information out there. You know, privacy in China is a very different issue, right, than privacy in the U.S. So it is a universal concern. Different governments in different jurisdictions are going to take different views of it. I think that what I would say is the technology and the capability got ahead of what legislation has been, and we're going to see legislation catching up to that. But it's a work in progress, and it's going to take time. And I want to remind people, though, also that as much as privacy is really important and everyone should have the right to opt in or opt out, there is so much value that comes out of information that's there. And so I think what's important to try and do is to try and make sure that we could obfuscate and we could actually use data in a way that doesn't put the individual at risk, or doesn't, put harm to the individual. So, for example, in the health industry, right, sharing diagnosis for any individuals, HIPAA, you're not allowed. There's, very, very tight controls over that. But information about kind of what's going on from a broader health perspective, being able to take the person out of it and still use the data, these are really important things, and society gets an enormous amount of value from it. So finding the right balance around the value and the use and how we can do it versus the things that start to, challenge our own privacy and our own values and things like that is yet to come. So apologies, I can't be more, specific on it, but it's an evolving area. So to the point, and I'll kind of go through these slides pretty quickly, but to the point, it's not like using these models is the answer to everything. And in fact, there's a lot of pitfalls that come into play when we think about it. Being able to explain why a model got to the answer that it did, especially when there's so much complexity that's embedded in the model. There's billions and billions of different iterations that we use these models for because they can do those billions and millions of iterations. But then when we ask the model, well, how did you figure that thing out, or how did you come to that conclusion? Being able to explain it becomes a harder thing to do. If you have a simple decision tree as a model, you can follow that path. Yes, no, you go here, and you can follow that all the way down to the answer. And things like neural nets and the complexity of some of the stuff that we leverage, it's not always as easily explainable. You've got stuff, we call it overfitting, and so where you've tried to make a model so precise that it becomes ineffective because it's only solving for very, very narrow sets of answers, that is also a risk. Regulatory and compliance, unethical, illegal things. Like one of the things in the bank, the bank that I work in, is there's very specific criteria around the different elements that we can use to make a decision about whether or not we lend you money. If these models then sort of take over, and even embedded in those models, they use those parameters to make a decision, that's a problem. And so we have to be very careful. We have to make sure that it's not only right, the data's right on the way in, but how the model is ultimately being used. And then finally, on data bias, you saw before, and I mentioned it with the chihuahua and the muffin. If you put bad data into it, you're going to get bad data out. Or if you put biased data into a model, if you put something in that values or puts more emphasis on one thing versus another, you're going to get a model that's biased. You're going to get something that ends up in results that are not nearly as objective as you might think. And so all these things are really important to think about when leveraging. So, what are some of the unintended consequences of using this software? Some examples here. Microsoft chatbot. Has anyone heard about any of these? I mean, they've been in the press, and so I don't want to bore you, but if Microsoft Chatbot is listening to a Twitter feed and learning how to curse and how to, the very negative behavior that you wouldn't want a chatbot to exhibit, then you can't have it learn from, different data sets that's going to teach it that. And that was what happened in that case. Google Photos, and did you guys also, have you heard about Google recently around sort of gender labeling and the fact that, so first of all, things like facial recognition and stuff, again, it has to, like the inputs into it have to be, have to be comprehensive. There's been a lot of facial recognition stuff as a result of, not having sort of a racial equality when the data is input into the model. And so, the machine has come out with sort of bad results. In addition, where it was labeling male versus female, Google recently came out and said, you can no longer determine gender just by, visual recognition. It's more than that. And so, as you can see, these are not straightforward implementations. And going back to, some of the questions around, what's appropriate, what's not, where can we use it, where does it need to be, validated, supplemented, because if left to its own devices, in a lot of cases, we can have very negative effects. So, I'm going to quickly go through because it's probably the most boring part, and we're getting deep into the session, so we'll see. Most of you are awake, so we'll see if we can keep on the track record. Okay, so I mentioned fraud. So JP Morgan, how is JP Morgan using machine learning AI in its processes? The one thing that I would add about the fraud, it's not only credit card fraud, it's things we call anti-money laundering, it's also check fraud. We have investment that's going on that's trying to indicate whether does anyone write checks anymore? Probably most of you don't, but there are many people that do, by the way. And how do you ensure that the right signature is there, that somebody hasn't tampered, with the check itself, and so investment going on. It's really important in fraud, though. Fraud is not about making sure we catch all the bad guys. Fraud is about making sure that we balance catching the bad guys with giving a good customer experience. Because if I take a model and I tweak it all the way to catch everyone, right, what it's going to do is it's going to find a lot, things that we call false positives. It's going to find things that you're doing as regular transacting that it's going to indicate as fraud. And the way we get as comprehensive as possible in capturing fraud is we become very conservative in what we consider fraud. But the idea is you as a customer don't want to be stopped at the cash register and say, I'm sorry, you can't execute this transaction. So a lot of what we do is around trying to create the right balance between the false positives and making sure that we're capturing absolutely as many of the actual bad transactions. Mentioned portfolio management. If you think about portfolio management, when you have a portfolio, that might be stocks, bonds, things that you invest in, and we do on behalf of our clients. What becomes an opportunity for our clients is where we can actually get market information out. We can understand what might be happening with a company before the rest of the market does. And we can do that through sifting through lots of documentation, things that are happening in the news that might indicate that an industry is suffering. And so we can apply what we call natural language processing to a lot of information, synthesize it, and find the opportunities to get ahead in terms of whether we want to buy a stock, sell a stock, make an investment. And so we've got that. Marketing. Does anyone bank at Chase? Yeah, some people, all right, there we go. So hopefully, hopefully, and you guys can give me feedback because we're constantly trying to make it better. But what we offer you, like whether we offer you, the opportunity to execute trades, or whether we offer you, a product because you've been spending on certain types of things, and we know that there's a deal happening on these things that you're interested in. And so, what are the things that we can predict that you may need, again, not so that it's creepy, right? So, going back to the question around privacy, we have a kind of creepy factor, and we don't want to be in the creepy realm, but at the same time, we want to create ease and opportunity for our customers and clients, and we want to show them information and things that they might not otherwise see, unless they were, looking really hard for it. And so marketing is another area. And then I'll just wrap this up with, voice ID. So when you call up, there's a lot of different elements to our voice that can be captured and, applied to identify when somebody is speaking. So a voice identifier, something that's unique. It's your fingerprint of your voice. And so this, the ultimate value in this is, when you call up to execute a transaction, one of the things that we spend a lot of time doing is authenticating that you are who you say you are.
Yeah. How do you handle fraud prevention when somebody doesn't? When somebody doesn't have a long purchase history with you and you don't have that much data to...
Yeah, so there might not be an absolute like for you, but we can map you to other like people, to other behaviors, things like that. Things around where you live, or other activities that you participate in. Again, it's not 100%, but what we're trying to do is get smarter about it, right? Use more data, more information. It doesn't always have to be yours personally. It could be a segment that you're in, or different things that we may know about your transaction that will allow us, better insights into it. So it might not be on the individual. It might get mapped to almost like a proxy to help identify where there might be fraud. But on the voice stuff, it's similar. It's like, how do you know that you're really you? How do you know that you're really you, so that when you ask to transfer, $5,000 to another account, I don't have to send you a code and you confirm back and we go through this rigmarole of what's your social security number and everything, right? Are there ways that we can actually use this kind of voice print to give us more confidence that you're you, and so that we can execute the transaction without putting our clients through a significant amount of interrogation? Okay, how's everyone doing? Okay, yeah.
A question about the voice recognition side of it. Say for example, I had an account with Chase Bank. I'm making calls, and you guys sort of map my voice. Say I move to another bank. What do you guys do with that data? Is it deleted or?
Yeah, I mean, there's certain regulations around when people are no longer customers, and so it's different depending on, like, we have certain regulatory obligations to keep data around for a certain amount of time. Again, it's to demonstrate if the regulators come back and they want to see activity done, but it's a combination of kind of the personal privacy stuff, as well as what our we'll say our banking regulations are on a particular type of transactions. So, I mean, we tend to, I'm laughing a little bit because I'm spending a lot of time in my day job on records management and the destruction of records management to make sure that, we are able to evidence our destroying of this data. But yeah, it will be sort of the least amount of time, or the greatest amount of time of the regulations of what we need to keep before. Okay, so, and by the way, if people have other questions, I'll leave my email. I don't know if I should do this, but I think so. I'll leave my email, and I'm happy to, answer stuff that we may not get to today if you're interested. Yeah?
So I heard that one of the drawbacks of machine learning is that it requires very fast quantities of data.
Yes.
So how true would you say is that, and then is that going to be a roadblock?
Well, I think that's very true. It is actually one of the features of the machine learning practice, that the more comprehensive and the vaster the data set is, the better off you are. Now, there are companies out there that are trying to solve for reducing the data set, like trying to, again, do some of the stuff I spoke about before, like map it to other data sets that are maybe comparable or, different characteristics, or you can generate data sets that attempts to be proxies for bigger data sets. But practically speaking, the models, think about it this way. The models need to learn how to behave. The more information you can tell the model and how to behave, the more effective that model is going to be. And so you can put very little data into your model, it's just not going to work very well. I mean, you'll have results, but you won't be happy necessarily with the results. And so that's the case. And the other thing that I'll just add, we are just generating as a society enormous amounts of data. In fact, arguably, we have a lot of data out there. It's not necessarily going after the next data that we need to collect. We have a lot of data out there that's sitting there waiting to be used and waiting for the opportunity to apply it to some of these problems. And so, hence why the slide about the fact that we can keep that data around longer, that we can mine it, we could put it in places where we could share it, is really an important component of why the popularity of it has exploded so much. I'm going to quickly go through the last two slides because I think it's important, and it's also something that we can leave with your teacher for future. And I promised my son I would give him a call out. So my son is studying data science up in Boston, and I've watched him over the last, he's a junior, and so he's got another year left after this. And he's had a couple of jobs that have also allowed him to get, and by the way, not at JP Morgan, so if anyone was wondering that, but he's had a lot of opportunity to apply data science to different kinds of activities. He worked for the New England Patriots. I know we're not Patriots fans in New York, but yeah, boo, exactly. Within their analytics team, and spent some time at another firm. But what I watched him, and I watched how he looked across a vast array of different kinds of resources. I would find that he was watching videos on machine learning, or accessing data sets, or experimenting with different tools that are out there. So as I was preparing to come here and talk to you, I asked him for a number of kinds of tools that he's used, things that he found valuable, from the perspective of being sort of a newly into this field, where were the places that he could go for information, and what was most helpful. So there's listed up here, there's publications, like reading about it and sort of connecting yourself to the community is, I think, really important. If you have an interest in it, you'll find a lot of the articles really interesting to read, to kind of read through. You've also got video, so if you're less of a reader and more of a visual individual, you can look at these series here, and they'll sort of, and a lot of this stuff. What I never really, I didn't grow up in this generation, right? If you need to change a tire, you go to YouTube and you learn how to change your tire. If you need to, fix the sink, you go to YouTube, you learn how to fix the sink. Well, if you want to do data science, in a lot of cases, you go to YouTube and you learn how to do, some of these skills and capabilities. So there's information out there, should you want to avail yourself of it. I think it's also important to say that the barrier to entry to do these things is not necessarily a 4-year degree in computer science with a PhD in physics, right? Like, there is so much capability that's at your fingertips. You can go into many of these environments and find the tools and tutorials that walk you through, this is how you get your hands on a data set. These are the different kinds of models and characteristics of the models. How do I make the data, go through the model and show me results, and start to learn how the process happens. So you don't need to be a programmer. And you don't need to have, this enormity of statistical skills or technical skills. You can actually do a lot of this stuff just by investing a little bit of time. There are, though, programming languages that people do and execute a lot of data science. Python is probably the most popular, but you can see here, and again, if you want to either take a picture or we can send you the links, ways to visualize data. Like again, the machine learning process has lots of steps, and so this is a little bit more detail behind each of those steps and some of the tools that are out there. And then finally, and to your point earlier about data, right? Data sets are not always easy to come by, and data is enormously valuable when you want to start to experiment and play around with these things. There are organizations on a regular basis who are announcing the availability of their data sets. They are, it's a lot of fun to go, fun, I don't know, you might not consider it fun, like I consider it fun, but there's a lot of opportunity to go in and sort of look around and then use that, extract that out to use it for experimenting and even, some research if you're interested. I'm done. Yeah? Any more questions, or are we? I know you have to file out, so I don't want to.
We have plenty of time. So any more questions? I'll come around with the microphone if anybody would like to ask any additional questions.
Hi. So you said that JP Morgan uses a lot of algorithms and machine learning to help its clients, for example, predict how the market is going to react. So I have a few questions about that. So recently, there was the whole coronavirus effect, and hence the markets have dropped since then.
Yeah.
Yesterday, the Federal Reserve cut its rates, and the market still went down. So how exactly does your algorithms predict that? Because traditionally, when the rates are cut, the markets should recover.
Yeah, no, I mean that's a great question, and it goes back to I think some of the stuff that I was saying before. Models give you insights, and certainly models that make assumptions around things that have happened in the past and how they will affect things that are happening in the future. And especially when you haven't seen something that's happened in the past that all of a sudden happens, and you don't exactly know what the results of that are going to be. Sometimes, right, the model isn't able to predict that. So I'll say two things on that. One is we have, for decades and decades, run processes around trying to predict kind of effects to the market, like things like value at risk. I don't know how familiar you are with the financial services, but as an owner of a portfolio, right, really understanding what's the likelihood of certain things happening. And what we discovered over time, which is not specific to machine learning models, but to all in particular, is when you think about risk management, when you think about like what could happen, it's not only the reliance on models, right? You have to also do things, and we call those things stress tests. Like the out of the box didn't happen before, but may happen in the future. And what does that scenario look like? What may happen? And we kind of force that particular scenario onto the portfolio, and we say, what would the reaction be? So it really goes to models are a great way to do this prediction. When it comes to something like whether or not we market a product to you, it's really easy to make the decision as to whether or not we do that, because there's very little downside or harm in doing that unless we piss off the client, which we don't want to do. But when it comes to like key decisions around like trading and what we're going to do, we put those models through, we complement them with other kinds of capabilities that the models are not necessarily going to see or pick up, and that's how we end up balancing that out. But yeah, who could have predicted that? Yeah. Yes.
This is less about AI, but how many programmers do JP Morgan hire a year? And if they do, can you become part of an investment team?
Well, when you say an investment team, I just want to make sure. So we have over 50,000 engineers across the world. That's JP Morgan's, and we hire I mean, there's a difference between higher entry level, right, out of school versus higher laterally, right? Because obviously it's not only through that avenue. We have people that kind of move around different industries and stuff like that. And we probably hire close to 5,000, somewhere around 10%, maybe a little bit more of the overall workforce every year. And I'm not sure I understood your last question about being part of the investment team, or, okay, all right, you can just email me that. But yeah, and by the way, it is so important, when we think about our workforce, and this wasn't meant to be a recruiting event, so apologies if I don't have all the numbers, but we absolutely value folks like yourselves who have been through an amazing education, who bring to an organization new thoughts and ways about doing things that are new and innovative and challenge the rest of the organization. So we put a lot of emphasis on our entry-level hiring and that element.
Hi, so when you were listing all the examples, I noticed most of them are machine learning, where you try to categorize certain data sets. But for stuff like deep learning, I was curious how that applies to the things you guys do. Since the example you showed with the Pong there's a specific goal of winning a game, and that's how deep learning practices it. So I was wondering how that will apply to the things you guys do.
How reinforcement learning would apply to JP Morgan as an example?
Yeah.
Yeah, I mean, we don't do a lot of reinforcement learning. As mentioned before, we have different kinds of problems that we're trying to solve for. We're trying to solve for better client experiences. We're trying to solve for, honestly, different revenue opportunities. We're trying to make sure that we've got the right risk management and controls in place as described. So we tend to use more of the supervised learning capabilities than the reinforcement learning per se. But yeah, if you go in, if you go to work for Tesla, where there's a lot of investment in kind of something like driverless cars or things, that's where you see the majority of that. We don't have a lot of reinforcement learning at the bank.
One last question.
So there are a lot of machine learning algorithms out there, and some are more open source, some are less available.
Yes.
So I was wondering how a big company like JP Morgan, do you write your own machine learning algorithms? Do you research them? Do you implement existing ones?
Yeah, that's a great question, and actually applies not only to machine learning but technology in general and how we think about do you buy it? Do you build it? And this is how I would think about it. Generally applied. If you're going to reinvent the wheel anyway, if it's something that's sort of out there and it's going to be more generic, then you're not going to make a better something or more nuanced of something that's specific to your business, then why not? Leverage it, pick it up, make sure that you can use it and make sure that the standards and how it was built and everything, are there and applied, but don't go build it yourself. If there's something that's missing out there or that you could build it, better. Because you've got either, more experts on it, then you go and you build it yourself and you choose whether or not it's, proprietary enough that you want to keep it, or whether or not, now that you've built it, you want to, contribute it back. But those are the kinds of things we think about. We also have a research arm for this in the organization. A woman by the name of Manuela Velosa, who came from Carnegie Mellon, who taught there, for a number of years and did research there. She runs our research function, and our research function is a little bit less about the practical, what we could use today, but more about the next 5 years, the next 10 years down the road. How is this stuff evolving, and what do we need to be investing in and doing research in, so that we can sort of position ourselves in a good place for a much, a more forward-looking view as to how we use this technology.
Well, thank you again for taking the time out of your day.